Hi everybody, and welcome back. Let's start with capturing this color chart. We don't need a ton of views. Probably before I said 8, we'll do 12. Just a loop of 12 steps, just to show you what it would look like, and that would be more than enough to use later for reference and to make sure that all the exposure calibration is fine. Even though we use all these April tag markers to do a lot of extra stuff, but it's still a good practice to start any new session or capture by capturing a color chart for the reference. Let's make sure that polarization works as expected, so we can see that specular appears and disappears. That's great. So it's off. Right now lights are running at 1/256 of their actual power, but you can see when I turn the ambient off, it almost there is no change. Well, there's a little bit. So when I fire the sequence, I'll turn that light off. So let's go back to our turntable thing. It already got disconnected, no problem. Let's go back, create content, turntable. Let's set it to 12. That should be good. Let's go back to our app and let's look at the. So according to all those settings, it tells us that the whole sequence is going to take 14.21 seconds. To be safe, let's assume 15 seconds. So in here we need to go and set it to 15. And that's pretty much standard functionality for any turntable software, and the idea is that it's going to get in position, it's going to issue a trigger, and it's going to wait for that long. Or in some other turntables, they would first turn, then wait for that long, then do the trigger, and then well, that would be the worst case. In this case, it will just do the right thing. It will trigger, then wait that long, then do the turn. So let's turn the light off. There you go. It's pretty dark. And 12, that's good. And now let's click record, and I'm going to step away. So in this particular case, while it's doing that, I hope that the mic can hear me from this distance. But essentially, yes, it looks like it's doing the right thing. The turntable works off the battery, so it's not connected to any power. It's a bit noisy. They're using DC motors and gears, but it does the job. For more heavy stuff, we also natively support PAMCO imaging turntables that use NEMA 23, if I'm not mistaken, with 10-to-1 or 50-to-1, even 50-to-1 gearboxes, so those can handle quite heavy loads. But if something that we don't support directly, that's what you see over here. It just turntable turns, then it triggers. We run through the whole sequence, trigger the camera. Meanwhile, it waits for some time, and that's what it looks like. Also, while it's doing that, in our previous videos when I talked about frame rates and acquisition speed and triggering and all that related stuff, One thing usually that people will say, well, a lot of these cameras in burst mode, they can do up to 10 frames per second or even more. And that is true, and in those cases pretty much sensor works as a video mode, so it keeps rolling, rolling, and rolling. The problem with consumer grade devices like this is that, for instance, with Sony cameras, and that's true with other cameras, is that as soon as you enable electronic shutter, they know that it's not compatible with speed lights, with those strobe flashes, and they basically disable it. And one way, for instance, when we used to use mechanical shutter, you could use that hot shoe connector and get that signal. So you basically have one pin that tells you when the sensor begins its exposure and when it ends it. And so we could basically synchronize the whole thing to that. So as soon as sensor starts capturing something, we can change the light and like right away, super quickly. However, in a lot of these cameras, that functionality is disabled, and we basically cannot, like, you're stuck with one, like 1.5 frames per second, basically. You know, there are cameras like, as I was mentioning, with global shutter, something like a recent Sony Alpha A9 III that uses a global shutter. However, it can capture faster, but it's limited in terms of resolution, only 24 or something along those lines megapixels. So there you go, we captured everything. Let's return to our original position, switch to our app, go and enable that. So that was 12. Let's go to view. So 312. Let's do a quick math here, shall we? So it was 12 times 24. 12 times 24, 288 plus 24 original ones that we took for the calibration, 312. So there you go, we'll look at the camera, we see 312, so we did not miss anything, everything was great. And back, and then we have spec, and then we go back, and so on. So there you go, so we got our color chart captured. I'm going to stop this video right now and take it out, and we'll process all this stuff and talk about it in later on when we will look at the software. And now we will switch to that octopus to doing the actual prop scan. Finally, off, on, off. There you go.